everyone, Jan to all. In this video lecture, I am going to teach you how the DFA is minimized, or we can say how we have to minimize the given DFA by using different methods. Mainly we have to use two methods. The first one is equivalence method and second one is Nerode-Myhill theorem. That is also called table filling method. I am going to next point. This is the table of contents. What is the meaning of minimization? Type of minimization. We have discussed two types of minimization. The first one is equivalence method and second one is Myhill-Nerode theorem. That is also called table filling method. And we have considered an example on this method. And in this video, we have only discussed about equivalence method because there is a big time which used for the discussion of Nerode theorem. This is the meaning of minimum. What is the basic means of minimization? Simplifying or minimizing a deterministic finite automata, DFA, by reducing the number of states while preserving its functionality. This process aims to create a minimal DFA, which is the DFA with the fewest possible states that accept the same language as the original DFA. That means we are going to minimize the number of states, and when we have to minimize the number of states, there is no change in the concept of machine. If the machine is accept a particular language, that machine after minimization must be accept the same language. There is no need to change the functionality of machine. That machine accept the same language as accepted before the minimization. Here, the minimization is crucial for optimizing the DFA complexity and efficiency. We have to use minimization because we want to reduce the complexity and we want to increase efficiency. If we want to increase the complexity of a machine, decrease the complexity of machine, and we want to increase the efficiency of machine, so that we have to use minimization. This is the main points or main topic of unit 1, which is used to discuss how to minimize the given DFA. This is the approach which is used in equivalence relation. As we saw in the first slides, minimization are two types. The first one is equivalence method and second one is table filling method. Here we have only discussed about equivalence method, how in case of equivalence method, we have to minimize the given automata. This approach relies on identifying equivalent state, which are states that we have identically for all possible input string. Equivalent state can be merged into a single state, reducing the overall number of states. In this method, we have to combine the states. After combining, we have to check, or before combining, we have to check same property must be for the combining states. If there are two states and the both state having same property, then we have to combine that state, otherwise no. If the property is not same, then we can't combine the states. If the property are same, then we have to combine the given state in a single state. This is the part of Myhill-Nerode theorem. This is also called table filling method. This is also called table filling method, TFM. In this method, we have to construct a table and take or mark table itself by some properties which is discussed in next video. This theorem provides a formal basis for determining state equivalence and is often used in conjunction with other method of DFA minimization. This method is efficient and this is the more effective method to minimize the given DFA. But here we have to only discuss about equivalence relation. Here this is the theorem which explains how we have to combine the given state in a single state. We have to write two states Q1 and Q2. Two states Q1 and Q2 are equivalent if both delta Q1 comma x and delta Q2 comma x are final state, or both of them are non-final state for all x belongs to sigma star. We want to combine Q1 and Q2. We combine if Q1 and Q2 both are final or Q1 and Q2 both are non-final. Otherwise, we can't combine. Means, if Q1 is a final and Q2 is a non-final, we can't combine Q1 and Q2. But Q1 and Q2 both belongs to final, we directly combine this state. Otherwise, don't combine. This shows the steps how we have to procedure follow in case of combining the states. The step 1, we have to write pi 0 equal to Q1 power 0 comma Q2 power 0. Here we have to classify final and non-final state in two classes. Q1 contain the set of final state and Q2 contain the set of non-final state. This is okay. Now, the second one is, we have to write here, Q1 is the set of final state and Q2 is the set of non-final state. Here we have to write Q minus Q1. Q is the set of all states. We have to subtract Q1 as a set of final state. Then the left symbol is called non-final states. Here, step 2, now repeat until pi k equal to pi k plus 1. We have to repeat this step until the previous and next step should be same. We have to repeat recurrently. This is a numerical which given a machine in the form of DFA. In this machine, there are 8 states including 0, Q0, Q0 to Q7. Total number of states is 8. And we want to minimize this state by using equivalence relation. First steps is, sometime you have to remove the dead state, but there is no need to here we have to consider. There is no need to you worry about the dead state. First, according to this method, first we have to draw a table. This is the straightforward method and we have to find solution efficiently. The question may be in the given of the form of diagram or it may be given in the form of table. If the diagram is given, then first we have to construct table, and if table is given, there is no need to draw the next table. We have to take decision on table. Otherwise, if diagram is given, then we have to first step, we have to construct a table for the given diagram. Here the diagram is given, that is the form of machine which we want to minimize. First, then we have to construct a table for this machine. Now we draw table. How we have to draw a table? We have consider this machine, count the number of state. There are 8 states, Q0, Q1, Q0, Q1, Q2, Q3, Q4, Q5, Q6 and Q7. First, in first column, like this. In first column, we have to write all state Q0, Q1, Q2, Q3, Q4, Q5, Q6 and Q7. Now, check for 0 and 1. Check for 0 and 1. Q0 input 0, Q0 input 0, the next state is Q1. We have to write here Q1. Q0 input 1, the next is Q5. We have to write here Q5. Same method used for remaining states. Q1 input 1, the next state is QC. Look at this. Q1 input 0, the next state is Q6. Q1 input 1, the next state is Q2. Next state is Q2. We draw this table using this method. After drawing the table, now time to separate the final and non-final state. First, in the given diagram, the final and non-final state is mentioned. In the given diagram, Q0 is the initial state. We mark here entering arrow, and Q2 is the final state. We mark circle. Now, we use equivalence method. First, we have to write pi 0. In pi 0, we have to separate final and non-final state. We mark Q2 is as a final state and remaining state are as a non-final state. And remaining states are, which one are remaining state? Q0, Q1, Q3, Q4, Q5, Q6, Q7. These states are non-final state, so that we have to write in a single brace. Q2 is the final state. We have to write in a separate brace. Now, we check one by one. We assume that these all states are a single state, but it can be possible that this decided after checking the condition. How we have to check? If a brace contains single state, there is no worry. There is no need to worry. Left that. Q2 is a single state. There is no need to check for other states because this is the single. Now, check for these states. Or these states are together. Check. Q0, Q1. We have to check table. The state Q0, Q1. For input 0, Q1 and Q6. Q1 and Q6 are in the same brace as Q1 is here and Q6 is here. Check for 1. Check for 1. Q5, Q2. Look at this. Q2 is here and Q5 is here. If for the single input, one state is one brace and next state is another brace, we can't write together. So that we do not write Q1 with Q0. Same procedure, we have to use same procedure, Q0, Q3. Same procedure, Q0, Q3, here Q2, here Q1. Q2 is a single and Q1 is here. Both not in a single brace, so that we don't write here Q3. Now, Q3, Q4. Look at this. Q0, Q4. Q0, Q4. Q7, Q1. Same brace Q1, Q7. Next state is Q5, Q5. That lies in the same brace. Q5, Q5. So that we have to write here Q0, Q4. Now check with Q5. Same Q0, Q5, Q2. Q2 is in separate brace and Q5 in a separate brace. So there is no need to check for 1. If the first condition is fail, we have not need to check the next state. If first condition is okay, then we have to check for 1. Now, this is the classification of Q0, Q4, Q6. After checking, the one state is Q0, Q4, Q6, and the next remaining state is this one. This also be verified. This Q1, Q7 together, this Q3, Q5 are together. We have to check in next step. Same, we have to write pi 2. Q2 is the single state. There is no worried about this. We have to copy same state Q2. Q0, Q4, Q6 is together. We need to check. First, we have to check Q0, Q4. Q0, Q4. We have to check what? Q0, Q4, Q1, Q7, Q1, Q7 together in the same brace. No need to split it. Q0 come with Q4. Now check with Q6. Q0, Q6. Q0, Q6, Q0, Q6, Q6, Q1. Look at this. Q6 is here and Q1 is here. So that we don't write Q6 with Q4, Q0 and Q4. We split Q6 in another brace. That means this three state comes in two states, Q0 and Q4 is together, and Q6 is separated because this not satisfy the property of equivalence relation. This is splitted. Now we have to check Q1 and Q7 same way. Look at the table, Q1 and Q7. Q1 is here, Q7 is here. Q6, Q6 in the same brace. Q6, Q6 is the same, is a single state. They lie in the same Q6. And now check for 1. Here Q2 and here also Q2. Here also Q2. This also lie in the same brace, so that we have to write Q1 and Q7. Same Q3 and Q5. After completing this step, we comes on the next step, pi 3. We check one by one. Q2, Q2, Q0, Q4, same. Q6, Q6, same. Q1, Q7, same. Q3, Q5, same. There is no change in the Q pi 2 and pi 3. That means we halt here. There is no need to compute the next state because pi 2 and pi 3 are same. Now need to decorate it. How we have to decorate? We have to use square bracket in the place of curly braces. There is no need compulsory to use square bracket, but we want to show in a proper manner, so that we have to use a square bracket in the place of curly braces. We convert sequentially. There is no need to change the place of the states. We have right here Q2, Q0, Q4, Q6, Q1, Q7, Q3, Q5. There is no change in sequence. We have to write, but only change the shape of the bracket. Here the curly braces, here we have to write a square bracket. If you are not interested in the changing the brackets, there is no need to change, but try to decorate it. Now, this is the table of converted minimized DFA. First, these are the states. We have to write this. How many are these states? 1, 2, 3, 4, 5. This are single state. This is a single state. This is a single, already single, and this is the single. We can rename it with another variable. It may be A, B, C, D, etc. But there is no need. There is no need. We have to write here states, but before writing the state, we keep in the mind the sequence of state try to manage. I again said there is no compulsory, but try to manage. First, we have to write Q0 because in the sequence Q0 is the first state, then Q1, then Q2, then Q3, then Q4. What state is coming with Q3, there is no matter, but try to write in a sequence way. Q1, Q7, there is no need, but you have to write in a sequence way. Now, we check for input 0 and 1. There is no need to check for both states. We take first state Q0 and check input for 0. Go on previous states. State Q0, input 0, the next state is Q1. We have to write state Q1 directly. Q1 means Q1, Q7. We have to write here Q1, Q7. Q0, input 0, the next state is Q3. Look at this. Q0, input 1, the next state is Q3. We have to write here Q3 or Q5. The next state is Q5, so that we have to write here Q3, Q5. That's it. Same State Q1 input 0, the next state is Q6, so I have to write Q6. State Q1 input 1, the next state is Q2, we have to write Q2. State Q2 input 0, the next state is Q0, we have to write Q0, Q4. State Q2 input 1, the next state is Q6, we have to write Q6. State Q3 input 0, Q2, Q6, Q6 and Q0, Q4. This is the method which is used to construct table for the given converted and minimized DFA. Now times 2, draw table for the given DFA. This is the most important things, how we have to give answer for a particular question. That should be proper minimization. Minimization question answered and with, always end with diagram. We never want to leave on table or a steps form. We have always tried to end with a diagram, so that we have to draw diagram for this given transition table, and this is the diagram. Here the first state is Q0, Q4. The next state is Q2, Q1, Q7, Q6, Q3 and Q5. This is the states which we have to converted after minimizing the given DFA. Firstly, we have to mark the states Q0, Q4, Q1, Q7, Q2, Q3, Q5, Q6. Now, check inputs for 0 and 1. On state Q0, input 0. What is the next state? That is Q1, Q7. On state Q0, input 1. What is the next state? That is Q5. We have to connect with Q3, Q5. But the direction of edge must be considered. On the present state, we move on next step, so that we have to mark the direction of the edge accordingly. And this is the final diagram of DFA. That should be the answer. This is the main answer of the given diagram. And this is represented in the form of transition graph. You must be keep in mind, the answer must be in the form of diagram in case of minimization. It may be possible that some answer in the form of table, or in some specific topic, the answer may be in the form of transition function. But in case of minimization, the answer must be in the form of graph, because the representation of the question must be important. This is the all about minimization of DFA. Now, we are going to summarize this topic in a short way. How we have to, firstly, we have to start with what is mean by minimization. Initially, we discussed minimization means reducing the number of states. There are two methods which are used for minimization. The first method is equivalence method, and second one is Nerod-Myhill theorem, that is also called table filling method. In equivalence method, question given in the form of table, or it may be given in the form of graph. That question may be in both cases, equivalence as well as Nerod-Myhill theorem, question given in the form of diagram, or it may be in the form of table. Firstly, we have to draw diagram to table. That means we have to draw a table for the given diagram. If question is given in the form of table, there is no need to convert in the another format. We have to work on that table directly. But if the question is given in the form of diagram, first we have to convert the given diagram into table. After that, we have to start the grouping of states. How we have to group that states? Initially, in first step, we assumed two sets. The one set is the for final states, and the another set is for the non-final state. In set of final state, we write all the states which are finals, and in set of non-final state, we write all states which are non-final. After that, we have to check the written states each together or not. By using equivalence method, we have to check for both input 0 as well as 1. For a present state 0, Q0, we have to check input 0 and we have to check input 1. If for the both input, the pair of states lie in the same brace, then we can say that these states are okay, otherwise not okay. By using this procedure, we go and check all states one by one, and until the two steps is not equal. At that point, when the two steps are equal, we stop and declare the minimized states. When we get minimized states, we have to rename that state in another variable, or we have to change the brackets in a square bracket. After that, we have to draw a table for the minimized states, and table is drawn as previous method, where we have to draw a table. We have to first write first column and try to write in the form of initial to next step. That means sequence of states. If Q0, Q1, Q3, Q4, Q5, then we try to write Q0, then Q1, then Q2, then Q3, then Q4. And after drawing the table, we can draw the diagram. Diagram must be in the form of same as we discussed. First we have to mark the nodes, that is states, and then we check input 0 and 1, and consequently we have to draw the diagram. This is the final answer of this question. This all about the equivalence method, not Nerode-Myhill theorem, or not a minimization. That second part of minimization is Nerode-Myhill theorem. If any doubts, you can comment in comment box. Thank you. Thank you very much.